While officially presented as routine exercises, the timing, scale, and coordination of the recent planetary defense drills have drawn significant attention from space analysts, defense experts, and astrophysicists worldwide. The European Space Agency (ESA) initiated this unprecedented sequence with a highly detailed 3-day simulation that involved its entire planetary defense infrastructure, including mission control operations, rapid response modeling systems, and an array of ground-based observation networks. According to reports by News, AZ citing the Daily Star, the ESA exercise went beyond the usual protocols, integrating real-time data analysis and rapid decision scenarios simulating a potential asteroid impact. Traditionally, such drills are planned years in advance, but the speed, intensity, and multinational coordination of this exercise immediately drew notice, demonstrating a level of preparedness and urgency rarely seen in space defense operations. Japan quickly followed with an accelerated asteroid impact drill that represented a remarkable departure from its past practices. The Japanese exercise coordinated civilian agencies, military branches, and commercial satellite operators to conduct a fully integrated scenario encompassing early detection, trajectory forecasting, impact mitigation strategies, and post-event response. The rapid execution of this drill surprised international observers, as many of the protocols included had been scheduled for phased implementation over the next several years. The United States Space Force also conducted a high-altitude orbital tracking rehearsal, which had originally been planned for late 2026, but was moved forward unexpectedly, further signaling the elevated priority being placed on these exercises. The synchronization of such activities across major spacefaring nations, each with their own technologies and operational philosophies, illustrates a rare and extraordinary alignment in global space security strategy. Even nations that typically avoid disclosing such operations, including Australia, South Korea, and Brazil, joined in the coordinated exercises. Their participation demonstrates a growing recognition that potential celestial threats are global in nature and cannot be managed unilaterally. These drills emphasize sophisticated data sharing systems designed to monitor what internal documents describe as high-velocity, non-gravitationally accelerated objects, terminology that appears to specifically reference the enigmatic object 3I/Atlas. The collaboration between nations that usually operate independently is a notable milestone in space operations, showing an unprecedented willingness to share sensitive information, coordinate across borders, and pool observational and analytical capabilities for a shared planetary defense goal. The sudden global focus on these exercises is largely due to the object's extremely unusual behavior. Observations of 3I/Atlas have revealed a number of anomalies that defy conventional astrophysical explanations, including rigid anti-tail jets that appear to move in defiance of physics, unexplained pulsations in brightness, and a persistent non-gravitational acceleration inconsistent with standard models of cometary or asteroidal motion. These behaviors have challenged scientists' predictive frameworks and forced them to consider alternative explanations for the object's dynamics. Among the leading hypotheses, astrophysicist Avi Loeb has suggested that the sunward anti-tail observed might consist not of gas emissions, as traditionally assumed, but of a swarm of compact objects traveling in tandem with 3I/Atlas. According to Loeb, if such a swarm exists, it would remain slightly closer to the Sun and offset by tens of thousands of kilometers, a pattern that observational data has consistently indicated since July. The implications of this swarm hypothesis are profound for planetary defense planning. If 3I/Atlas is accompanied by multiple smaller objects rather than being a singular body, the challenges involved in tracking and mitigating a potential threat become significantly more complex. Each object in the swarm would possess its own mass, trajectory, and orbital behavior, requiring the expansion of sensor networks, the deployment of additional observational satellites, and the development of faster response capabilities. Conventional tracking systems designed for single-object monitoring are inadequate in this scenario, explaining the accelerated and intensified global drills. Defense analysts have emphasized that preparing for a swarm would be a dramatically more demanding and resource-intensive task, essentially transforming the planetary defense landscape. This heightened activity has coincided with a notable shift in international collaboration regarding space technologies. Surveillance satellites, deep space infrared monitors, and other high-tech observational platforms, assets that would normally trigger geopolitical concern, are now being deployed with minimal resistance from rival nations. ESA's €22, 1 billion expansion of its planetary defense capabilities was approved with unusual speed, reflecting a global consensus on the urgency of readiness. Similarly, U.S. procurement documents indicate accelerated contracting for advanced tracking platforms, showing that governments are prioritizing the rapid deployment of technological solutions to monitor anomalous celestial objects. The International Asteroid Warning Network, IWN, has also updated its protocols to allow temporary integration of classified sensor data for analyzing non-standard hyperbolic bodies, illustrating that the international community is willing to temporarily set aside conventional data restrictions in the name of planetary safety. Observational data of 3I/Atlas continues to confound astronomers and astrophysicists. The object has exhibited irregular patterns of acceleration and deceleration, unpredictable brightening, and rotations inconsistent with those observed in known natural celestial bodies. Its physical and dynamic characteristics challenge the foundational assumptions of orbital mechanics, raising questions not only about the object itself, but also about the completeness of current models of cometary and interstellar bodies. Some researchers speculate that these anomalies might indicate artificial or engineered components, while others argue for the possibility of unknown natural processes. Regardless of the explanation, the object's behavior has prompted unprecedented global coordination and rapid implementation of defense strategies that would normally take years to develop. As the December 19th approach of 3I/Atlas draws nearer, governments are increasingly treating the anomaly as both a threat and an opportunity. While early detection and planetary defense are obvious priorities, the current situation also allows for a real-world stress test of defense systems and international coordination on a scale never before attempted. Exercises once considered purely theoretical are now operationally tested, involving real-time monitoring, simulation of multi-object scenarios, and joint decision-making among multiple nations. Analysts have noted that these drills have the added benefit of strengthening relationships between space agencies, defense organizations, and commercial satellite operators, laying a foundation for long-term collaborative frameworks in planetary defense and space situational awareness. The convergence of these factors, the anomalous behavior of 3I/Atlas, accelerated multinational drills, deployment of advanced observational technologies, and high levels of international cooperation, paints a picture of a world rapidly adapting to the realities of cosmic hazards. What was once considered speculative planning is now operational reality. Governments are demonstrating that planetary defense is not merely a theoretical scientific concern, but a strategic necessity with long-term implications. The case of 3I/Atlas highlights how a single unpredictable object can catalyze global preparedness, drive rapid technological advancement, and reshape international policies governing space security and defense. Moreover, this coordinated global response could have lasting consequences beyond the immediate focus on 3I/Atlas. The accelerated development of advanced tracking platforms, data sharing systems, and orbital monitoring satellites strengthens the ability of nations to respond to future celestial threats, potentially years ahead of schedule. Lessons learned from these exercises are likely to influence the design of new spacecraft, sensors, and data integration protocols. At the same time, they may encourage the establishment of formal international agreements for rapid information sharing and joint response planning, creating a more resilient global network prepared to handle a wide range of cosmic anomalies. In summary, the recent planetary defense exercises demonstrate the growing urgency, sophistication, and international cooperation surrounding space security. From the ESA's extensive three-day simulations to Japan's accelerated drills, the U.S. Space Force's forward-deployed tracking exercises, and the participation of nations like Australia, South Korea, and Brazil, the global response has been both swift and unprecedented. The unusual behavior of 3I/Atlas, including its anti-tail jets, irregular pulsations, and non-gravitational acceleration, has acted as the catalyst for this rapid adaptation. If the swarm hypothesis proves accurate, the planetary defense landscape will require new technologies, faster response capabilities, and expanded international collaboration to address the risks posed by multiple independent objects. As the December 19th approach draws closer, these efforts not only aim to ensure the safety of the planet, but also mark a transformative moment in how humanity prepares for and responds to the unknown challenges of the cosmos. The exercises, technologies, and agreements forged in response to 3I/Atlas will likely set a precedent for decades, shaping the future of planetary defense, space policy, and international cooperation in an era where celestial anomalies can no longer be ignored or treated as distant possibilities.